In this video, we're going to solve CAPE 2024 Pure Maths, Unit 2, Question 1. So part A reads, given that 3y squared minus 4xy plus sine xy is equal to 5, find dy dx. This question is a problem all about implicit differentiation. So let me just remind you how you do implicit differentiation. Let's add something like y cubed. How do I find d dx of y cubed? What I have to do is I have to just differentiate y cubed normally, like using the regular differentiation rules, and then at the end, I'm just going to multiply by dy dx. The reason you're doing this is because of the chain rule. So the way I do this, for example, is how do you differentiate y cubed? First thing is you just bring the power down and then subtract by 1, so it'd be 3y squared, and then at the end, I multiply by dy dx. So this is how you do implicit differentiation. Now let's actually solve this question. So the first thing I'm going to do is I'm going to differentiate. So let's write the equation. 3y squared minus 4xy plus sine xy equals 5. Now let's differentiate with respect to x. So the right-hand side is going to just be 0. The real issue is how do we find the left-hand side? So if we just do it by the rules, the first term is just from the rules, it'll just be 6y dy dx. The second term is a bit complicated because it's the product of two things. But basically, you just have to use the product rule from differentiation once again. All of the rules of differentiation will still apply, it's just that whenever you have a y, at the end you just have to multiply by dy dx. So for example, here it'd be minus 4. Let's say I differentiate the x term first, it'd be minus 4. When I differentiate x, I get 1, so it'd just be minus 4y. And then if I was to differentiate the y term, minus 4x times dy dx. Because if I differentiate y, it'd just be 1, right? With respect to y. Okay, now the last term, it's a function of a function. It's sine of x times y. So I have to use the chain rule. What does that mean? I have to differentiate the outside function first. So that's plus cosine of xy. Then I have to multiply by the differential of the inside function. So that means I have to find what d dx of xy is. And again, this is the product. So what I'd have to do is I'd have to use the product rule. And if I was to do that, let's say I differentiate the x term first. So when I differentiate x with respect to x, I get 1. So that's just y, and then plus x here times dy dx. And the right-hand side, if I differentiate 5 with respect to x, I just get 0. So we're not quite done, because it asks us to find dy dx. And to do that, we'd have to solve for dy dx in this equation. So what I'm going to do is I'm going to just collect all the terms with dy dx, and then factor the dy dx from them. So dy dx times 6y minus 4x, and then here there'll be plus x cosine of xy. That's this, and then minus 4y plus y cosine xy equals 0. So now the last step is to just firstly bring these on this side, and then I'll divide by this. So if I do that, I got dy dx equals 4y minus y cosine xy all over 6y minus 4x plus x cosine of xy. Okay, now let's do part B. Part B asks us to differentiate cosine inverse of 3x minus 2, expressing our answer in the simplest form. The main thing that we have to know, you have to remember, is that d dx of cosine inverse of x is equal to minus 1 over the square root of 1 minus x squared. That's the thing that you need to remember, because then all I have to do is use the chain rule, because then what this means is that d dx of cos inverse of 3x minus 2, differentiate the outside function, it's just going to be, which is the cos inverse, so that's going to be 1 minus 1 over the square root of 1 minus, and the input now is 3x minus 2, so it's going to be 3x minus 2 squared, and then times the derivative of 3x minus 2 with respect to x, and that's just times 3. So then that's minus 3 over the square root of 1 minus 3x minus 2 squared. And since I said to express our answer in the simplest form, I'm just going to expand the square here. And if I do that, you get minus 3 over square root 1 minus 9x squared plus 12x minus 4. And then that's minus 3 square root of minus 3 plus 12x minus 9x squared. Okay, and that's all you really need to do for this. Okay, part C, the first part is asking us to use partial fractions to show this thing. Whenever asked to do a partial fraction question, first thing you need to do is factorize the denominator. And a little helpful hint here is that they told you that these are the partial fractions that you're decomposing into. So you'll indeed see that if I factorize 3x squared minus x minus 2, it is actually just equal to 3x plus 2 times x minus 1. If I do the multiplication, you'll see, okay, this becomes 3x squared minus 3x plus 2x minus 2, which is 3x squared minus x minus 2. So this is the factored form. And the way that we do partial fraction decomposition is we're going to say, okay, like this is equal to a. We have no repeated factors or anything. It's just a simple one. So this is a over x minus 1 plus b over 3x plus 2. And there are a few ways you can do it from here. What I'm going to do is I'm going to do the algebraic way, I guess. So I'm going to multiply both sides, multiply by 3x squared minus x minus 2. So if I do that, the left hand side just becomes 2x plus 1. And then the right hand side, because 3x squared minus 3x minus 2 is equal to 3x plus 2 times x minus 1, I can write it as a times 3x plus 2 times x minus 1, and then it was over x minus 1, plus b times 3x plus 2 times x minus 1, all over 3x plus 2. And the nice thing is that these factors are going to cancel, right? So it becomes 2x plus 1 equals a times 3x plus 2 plus b times x minus 1, which now is equal to 3ax plus 2a plus bx minus b, which is equal to 3a plus b x plus 2a minus b. And what this means now, this is supposed to be equal to 2x plus 1. So if I compare the factors, that means that 3a plus b equals 2. And also 1, or let's say 2a minus b equals 1. So I just have to solve simultaneously for a and b. The way I'll do it is if I add these two equations, I got 5a on the left-hand side because the plus b and minus b will cancel, equals 3. So therefore a is just 3 over 5. And then therefore, if I just substitute that into any equation, I'll just do the second one. So that's 2 times 3 over 5 minus b equals 1. Therefore, 6 over 5 minus b equals 1, which implies that b is equal to 6 over 5 minus 1, which is just 1 over 5. So now if I just substitute back into my original expression, I got my original expression being this here. Oops. It's that I got 2x plus 1 all over 3x squared minus x minus 2. And a is 3 over 5. So I can write this as 3 over 5 times x minus 1 plus 1 over 5, 3x plus 2. Is that the same thing? Yes, it is, right? So we've shown what they asked us. Now, next part is going to ask us, this is a very common combo question that they'll ask. They'll first ask you to do a partial fraction decomposition and then use the partial fraction decomposition to compute an integral. So they're asking us to now compute this integral of the same expression. So by what we just showed, this is equal to the integral of 3 over 5 times x minus 1 dx plus integral 1 over 5 3x plus 2 dx. And then I can just do 3 over 5 ln x minus 1 here. And then here it'll be, let's do this one. Let's say I let u equal 3x plus 2. So therefore du is equal to 3 dx. So then dx is equal to du over 3. So then this becomes 1 over 15. If I just pull the 5 and the 3 out, 1 over 15 integral 1 over u du, and that's just ln u. That's 3 over 5 ln x minus 1 plus 1 over 15 ln u, because the integral of 1 over u is just ln u. And then u was 3x plus 2. This. And then last thing I just add plus c, right? Because you always have to add. Part D now reads, given that x is equal to 2t minus sine t and y is equal to 1 minus cosine t, find d2y over dx squared. This is a question about parametric differentiation because they're giving x and y in terms of another variable t, and then they're asking us to find dy dx. First, or d2y and dx squared. First thing we should do is we should find what dx dt and dy dt are. So dx dt is just 2 minus cosine t, and dy dt is just sine t. That's because the derivative of sine is cosine and the derivative of cosine is minus sine. Now, what's dy dx? If you use the chain rule, dy dx is equal to dy dt all over dx dt. You can think of it as cancelling fractions if you want. So then this is equal to sine t all over 2 minus cosine t. So that's dy dx. How do we find d2y over dx squared? Well, we know, okay, first thing I'm going to do is I'm going to call this z. So z is just dy dx, right? And we have an expression for z parametrically. Okay, so now what is d2y over dx squared? It's literally just the derivative with respect to x of dy dx, meaning that we're just differentiating twice. But we just call dy dx z, so this is the same thing as just dz dx, right? And then if we use parametric rules again, that's going to be dz dt all over dx dt. So really what we have to do is we have to find what dz dt is. So let's find that here. Now, z is the quotient of two things. I'm going to use the quotient rule. So dz dt now, the denominator is going to be 2 minus cosine t squared. And then the numerator is going to be v du dx. That's going to be 2 minus cosine t. And du dx is just cosine t. Minus u, which is sine t, dv dx. And dv dx is also just sine t. So if I was to simplify this a little bit, just box this off. If I simplify this a little bit, it becomes 2 cosine t here minus cos squared t minus sine squared t all over 2 minus cosine t squared. And then cos squared plus sine squared is 1, so you can simplify this a little bit more as 2 cos t minus 1 all over 2 minus cosine t all squared. So that's dz dt, and we know what dx dt is as well. So if I put all these things together, it's 2 cosine t minus 1 here all over 2 minus cosine t all squared, and then all over 2 minus cosine t. So if I put these things all together, simplify a little more, 2 cos t minus 1 all over 2 minus cosine t cubed.